This is a Seritag Pro Series NFC tutorial explaining how authentication NFC tags work and how they can be used. Let's first look at the fundamental difference between a standard NFC chip and an authentication NFC chip. A standard NFC chip, such as NXP's NTAG224, allows data, such as a URL link, to be stored in the user memory. While these chips can be used to identify a product or item, there's nothing to prevent the data being duplicated to another tag and into hundreds of counterfeit products. The code is static and never changes, and clearly the same problem also exists with QR codes. Authentication chips such as NXP's NTAG426, 223, 224 or 424 or the EM-Link chip work differently. A unique dynamic code is generated on each scan, which means that any tag data copied will be old and out of date. This system offers a substantially increased level of counterfeit protection over standard NFC chips. To be clear, NFC authentication tags have been around for a long time. They've been used in transport and ticketing for many years. The difference is how the functionality can be accessed. Simply, the old chips encrypted information within the chip, and special code, apps or readers were required to access the data. The new generation of chips dynamically substitutes authentication data into the URL link presented on a tag scan. This means that you don't need any special app or software to read the tags and check for authenticity. So let's have a closer look at how the chips actually work. When the authentication chips are encoded, we store not only a URL link, but also a unique key. So, in this example, we'll encode a link to Seritag.com and also encode a unique key, in this case ABC123. The unique key is hidden within the memory and cannot be accessed. When the tags are scanned, an encryption algorithm takes the scan count, possibly the ID or some other chip data, and combines this with the unique key to generate an authentication code. In this example, the code is A43FD2. When we encoded the tag, we also told the chip where we wanted this code to appear within our URL. So when the chip presents the URL on scan, it displays our URL link and dynamically substitutes the authentication code into it. Note that it never displays the key itself, just the result of the algorithm that uses the key. This combination of tag ID, scan count and auth code can then be verified on the destination server, which also stores a copy of the key and undertakes the same process. Once the scan count and therefore the matching auth code has been used, the auth server marks it as no longer valid, meaning that it cannot be used again. And this happens on every scan, because as the scan count increases, the data being used in the algorithm changes and a new unique authentication code is generated every time. Now there are three main ways to use authentication NFC tags. Firstly, with an API, where typically two servers will be involved. The NFC tag links to the first server, which would typically belong to a brand or company that makes the product. The brand server then makes a behind-the-scenes API connection to an authentication server to check the code, and then the brand server will respond. With a redirect system, the tags are typically linked to a management system first. The management system checks the codes and redirects, depending on the result, to different pages on the brand server. Or a direct response system, where the tags will link to either a management server or the brand server, and that server will check the code itself and respond directly. So let's have a look at each of these in detail. With the API system, there are typically two servers involved. So one server is handling the response directly to the phone user, and the other is handling the verification of the NFC codes. And this is how it works. The user scans the authentication NFC tag with their phone. This generates the unique auth code dynamically within the URL link. The URL link directs the user directly to the brand server. The brand server then extracts the tag ID, scan count and auth code from the URL, and behind the scenes passes this information to a second server, the authentication server. The authentication server checks the codes and responds with a pass or fail message, and the brand server will then respond to the user on the status of that tag. The redirect system will typically again use two servers, an NFC tag management system and a brand server. In this example, we'll use our Ixkio tag management system. The user scans the authentication NFC tag with their phone. This then directs them to the tag management system, which extracts the tag ID, scan count and auth codes. The management system then checks these authentication codes and immediately redirects the user to different pages on the brand server, depending if the authentication passed or failed. This happens so quickly the user isn't aware of the redirect. If required, additional tag parameters such as the tag ID can also be passed through to the brand destination server as required. This might be so the brand can show specific data for that tag scan, such as a particular product or message. In the direct response model, only one server would typically be required. The user scans the NFC tag and is connected either directly to the brand server or to a management server. That server then extracts the codes, handles the authentication and responds directly. This may be a full response, perhaps with images of the product and so on, or might just be a simple authentication pass or fail screen. So why use authentication NFC tags? It's estimated that the counterfeit market will be valued at $3 trillion in 2022. And it's also not just the obvious items like luxury clothing or goods. Pharmaceuticals, replacement parts for everything from automotive to boilers, computers and even aircraft parts, building material, food and drink, the list goes on. The vast majority of these items can be protected with the use of authentication NFC tags, which can help protect brands, protect businesses and reputations, and even help protect lives. And there's more. The recent explosion in the NFT market is changing the way we interact with online or virtual goods. But in many cases, these online items can be linked to physical items. Authentication NFC tags secure the physical, while blockchain tech can secure the digital. The connection between physical, digital, and ultimately the Metaverse will expand products across the digital threshold. To get started with NFC authentication, talk to Seritag today. Thanks for watching, and don't forget to subscribe.